Now let's go with our final case, which will give us the final solution. Now just using the same formula as here, if we just treat only like one single digit as 2, we check that this is already within the range of 1 and 9, right? If it's starting with 0, then the whole DP would be 0 and our solution would be 0. But here we see that it's between 1 and 9. That's why we have to use this formula again, because this is in a continuation of whatever we have already calculated with the previous subproblem with DP1. We already calculated that what is the DP of what is the number of ways to decode with DP1, our subproblem. So we just continue that this now this digit is also valid, so it would be the continuation of whatever we have already calculated in DP1. So let me do that. So using this formula again, if I just use this formula, it would be starting with 2, right? Because DP of 0 would be starting just a continuation of DP of 1. So in that case, we start with our base condition as 2. Now, again, now we have to check for 2 digits first and 3 digits all together. So, but we have noticed one thing here, right? At the max, because our range is only from 1 to 26, so we can only like have a valid number which is only having 2 digits, right? We cannot take 3 digits at all, because it would be like 100, 226. 226 way out of the range. We can only choose like 2 digits at a time maximum. We cannot take more than 2 digits. And also the range that we have already discussed, that if this once unit is starting with is 1, then this can be anything between 0 to 9, then it's valid. But if it's starting with 2, then this can be only between 0 to 6, 22, 20, 21, 22, 26. So this is all the condition about. And whenever we see 0, it will be always the DP would be 0 for the whole DP, for that particular index. Okay, so let's go with this. So here now I take these 2 digits. So we check that first, that this is 1 or 2 only. So here in this case is 2. And then we check this, that it should be between 0 and 6. So this is already valid. So this would be again counting to like one more count, or one more way to decode it. So here we can also write it down, right, like this, right? So we have just taken 2 and 2, and now we can the same formula as here, right? When we are actually using DP of I is equal to DP I plus 1. So similarly, we calculate that this is like total 1, and then the leftover digit is 6 already. So this can be written as a formula. So we are seeing a pattern here, right? So the pattern what I was talking about is that DP of 0 is equal to DP of 0 already. I mean, by this base case that you already got, that DP1. So this is our DP0 has already been changed to 2. So we'll use this DP of 0. And once we have calculated whatever is the DP0 for the next 2 digits, so it should be 0 plus 2, right? Whatever is the DP we have already calculated for 6. So that's why it would be DP of 0 plus DP of 0 plus 2. Should be 0, not 2. Okay. Or in other words, we can, the same way as we have generalized this formula, this can be again generalized as whether if we have got like more digits here, like say, if we have got say 1, 2, 2, 6, for example, in that case also it would be, say, just give me an example here. We have got 1 here. So if we have got one extra like digit here, 1, for example, in that case also the same formula would have been gone, that DPI would be DPI plus 1. So whatever for DP of 0, it would be DP of whatever we have calculated already. And once we take 2 digits together, because maximum we can take 2, after taking 1, it would be only 2, because we cannot take 122, 3 digits. It's already outside of range. It can be maximum 2 digits at a time. So once we do this 1 or 2, this is also a valid number. It can be decoded to a particular letter. So that's why it would be again the same formula, that it would be dp of this plus whatever we have already calculated for up till this. So this dp of these two digits. So it would be I plus I plus 2. It's very much similar to how we solved the Hausdorff problem or the Fibonacci series, for example, climbing stairs and all, where we are only concerned with the two indices. We only because of the range given here, it cannot be more than 2 digits at a time. So that's why this formula can be generalized like this. Let me remove this. So here, this particular formula, this is exactly same as if we just do dp of I is equal to dp of I plus dp of I plus 2. So if we do this, we already know that this. Let me just go back to the same example, that 22 is a valid digits to be encoded, to be decoded. Sorry. So this will result me in 2 plus 1, right? Because dp of 2 we already calculated as 1. So, and dp of 0 was 2 before, so it would be 2 plus 1. dp of 0 is, yeah, so this would be, final result would be 3. So this is our final solution, and we just put for the whole string given as 2 to 6, this is our final solution. So let's revise this algorithm again. We started with the base case here, and we checked that each individual digit which we are considering right now, that is within the range of 1 to 9. If it's 0, we mark dp as dp for that index as 0. If it's between 1 to 9, it's valid, and that's why we counted our ways as 1. When we considered for 2 digits, 2 and 6, but first of all we have to start with the individual digit first, like started with 2, and 2 is again within the range 1 of 9. So it means that it's in the continuation of whatever we have already calculated for dp of 2, the base case first. That's why we came up with this formula, that it would be, it's a valid. If it would have been 0 or anything, if it would have been 0, then the dp of 1 would have been 0 immediately. But if it was between 1 and 9, that's why we had a continuation of that, and the base case was 1. Now we considered the 2 digits together, 2 and 6. We found again the range is 26. It's within the range. If it was like 1, then it would have been 0 to 9. If it would have been 2, then it would have been 0 to 6 in the ones unit. Any other value, if it is 0, then the dp of 1 would be immediately 0. And it was like 3, 4, 5, 3 to 9, whatever other digits, then in that case also, that condition would have been 0, and we will only left with the one case. Because we are able to find 26 as one case, so that's why it was 1 plus 1, which is 2. And then finally we went to the final case, again using the same approach. 2 individual 2 is a valid between 1 to 9. That's why we started with dp of 0 is equal to dp of 1 using this formula, and we got 2 as a base case. And then we checked for 2 and 2, and we found that 2 and 2 are also the valid range between this range 20 to 26. So that's why we came up with this generalized formula that whatever we have calculated here, if it is a valid case, then it would be dp of this 0, which we already calculated here, plus 2, but like dp of 0 plus 2, which is this one, which we have already calculated here. And then we came up with this formula as well. So this was all about this dynamic programming approach, bottom-up approach, where we always started with the base case, and then we try to see whether we can generalize it and reuse the problem that we have already solved. So in the next video, we will solve the same approach that we have created here in Java and submit it in LeetCode. So see you all in the next video.